Today we're looking at the last lesson, last objective in 1.2, which is finding distance not on a number line, but on a coordinate plane. And this is going to come from page 18 in your textbook. Our relationship in words for this type of problem is distance on the coordinate plane. So here's our relationship in words. Okay, and this formula here is actually a form of the Pythagorean theorem, and I want us to see why. If we were to take these 2 points, we could extend these to create a right triangle. And the Pythagorean theorem would say, if I call this a squared and this b squared, then this distance of this segment here, or the length of that segment, would be c squared, the hypotenuse. So we know from Pythagorean theorem, c squared equals a squared plus b squared. And if we were to solve that just for c, we would take the square root of both sides, giving us square root of c squared is just c, equals the square root of a squared plus b squared. But what is a and what is b? If we look at our diagram here, we see that our first point has the coordinates x1, y1. So that just means it's whatever our first point is. Maybe in this case that's 2, 2, maybe it's 2, 3, maybe it's negative 3, 6. But we have x1, y1, and our second point has an x2, y2. So this distance on the x-coordinate is our whatever our first x-coordinate is. This is our second x-coordinate. And we know from our previous objective, a distance on the number line is the second coordinate minus the first coordinate, and that we take the absolute value of that. So we could say that a, or we'll use a blue here, we could say that a equals the absolute value of x, my second x-coordinate, minus my first x-coordinate. And then when trying to find b is this segment here. And this segment has a lower y-coordinate that's the same height as this right here, which is y sub 1. And it has an upper coordinate right here of y sub 2. So just like our distance on the horizontal number line is our absolute value of our second value minus our first value, our distance on the vertical number line, or this right here, is going to be our second y value minus our first y value. And we're going to take the absolute value of that for distance. All right, so how do we take this and this and this and make it into this? Well, our distance c is this segment PQ. And then we want to take a and square it. So that means we're going to take x sub 2 minus x sub 1 and square it. When we square a number, it always makes it positive, so we don't need the absolute values anymore. This is now PQ, so I substituted C for this right here. PQ equals the square root of, and we'll do this one. This is our blue. A is x sub 2 minus x sub 1, that just means our second x-coordinate minus our first x-coordinate squared, because it's a squared, plus our b, which is y sub 2 minus y sub 1, or our second y-coordinate minus our first y-coordinate, and then that b is also squared. And that is what gives us this formula. Whether you write all that down or not, You've already either done it at this point or you haven't, but I want you to see where this formula comes from so we can understand. This is my second x-coordinate. This is my first x-coordinate. That's my second y. That is my first y. And these little numbers at the bottom, if you haven't seen them before, the format just for numbering and format is called a subscript. And so we read this x sub 2. And in this case, it just means the second x-coordinate. It's a label. It's not a numerical value. Okay? So we have this example. I'm going to erase this so we can focus, which is to find the distance CD if C is -4, -6, and D is 5, -1. And our first thing to note is our relationship in words. Because we're finding CD with x and y coordinates instead of just a number line, this is going to be distance on the coordinate plane. Okay, and then the equation for that is going to be our distance D equals the square root of our second x-coordinate minus our first x-coordinate squared plus, remember that's a squared plus b squared, our second y-coordinate minus our first y coordinate squared, because it's a b squared. Okay? Then we want to identify and label our known variables. What's going to be very helpful here, choose one coordinate to be your coordinate 1, choose a coordinate to be your coordinate 2. So this is my x coordinate for coordinate 1. And this -6 is my y coordinate for coordinate 1. This is my coordinate 2. This is my x sub 2 coordinate. This is my y sub 2 coordinate. So now I can list these out here. X sub 1 is -4. Y sub 1 is -6. X sub 2 is 5. And y sub 2 is -1. Those are all of my coordinates. And now I can combine these two steps in order to find a specific formula for this situation. So my distance, which in this case is CD that I'm trying to find, CD equals the square root of, right, x sub 2, which was 5, minus x sub 1, which was -4. And again, we need to watch these double negatives. That's 5 minus -4. Quantity squared. So I'll copy this down here. X sub 2 was here. X sub 1 was here. And notice there's a negative in between my x1 coordinate and my x2 coordinate. Plus the quantity, copying down my plus and my parentheses, y sub 2. Y sub 2 is -1 minus y sub 1, which is -6. Quantity squared. That's the other thing that we'll often miss is squaring. Okay? Then we want to solve for the unknown, which is going to be a lot of simplifying. I should have left some extra space here, but here we are. CD equals 5 minus -4 is going to be 9 squared plus -1 minus -6 is going to be 5 squared. So CD equals 9 squared is 81, plus 5 squared is 25, which is going to be 100, square root of 106. Now, we do need to check, we need to simplify this radical. Are there any perfect squares that are a factor of 106? 106 itself is not a perfect square, so I'm going to start with half of 106, which is 53. Not only is 53 not a perfect square, it's a prime. So 106 is 53 times 2, so this will not simplify any further. So my final answer, CD, equals the square root of 106. And this is known as my exact answer when I use an unsimplified radical. If I put this in my calculator, that would be an approximate. What my calculator gives me is an approximate answer. I use 2 tildes that says that is an approximate, it's an estimate. I round it. We're not going to do that. We are just going to do our simplified radical. All right, one more example of this type of problem. We want to find the distance mn, where m is 2, 4, and n is -3, -2. So my general formula distance is the square root of my second x-coordinate minus my first x-coordinate squared, this is my a squared, plus my second y-coordinate minus my first y-coordinate squared. That's my b squared. I want to label, if this is x, then this is x1, or sorry, if this is 0.1, sorry, that's 0.1, this is x1 and y1, this is x2 and y2. All right, so I've labeled, we'll go ahead and, this is the shorter way when I don't require all the steps. We would do this. This is the minimum amount of work. We do not want to do any less than this. We're not going to fill in our values. I have parentheses x sub 2, which was -3, minus x sub 1, which was 2. Quantity squared plus y sub 2, which was -2, minus y sub 1, which was 4. Quantity squared. So we watch our signs, we watch our squares. Now we can simplify. Oh, also this is now, we're finding mn specifically once we've put in our values. So mn equals the square root of -3 minus -2 is -5. -5 squared is 25. At this step, once I don't have squares anymore, I should have all positive numbers in here. -2 minus -4 is -6. -6 squared is positive 36. Remember, no negatives once our squares are done. So mn equals 25 plus 36 is 61. And 61 is prime, so there are no simplifications to be done here. And this is done. For the purposes, if you're working on a problem in IXL and it needs you to simplify, let's say, just as a reminder, if we had the square root of 54, then remember we checked the highest perfect square factor. 54 is not a perfect square. Half of that is 27, which is not a perfect square. My next perfect square under that is 25. Not a factor. 16 is not a factor, but 9 is. So this could be written the square root of 9. 54 is 9 times 6. Square root of 9 times the square root of 6. And the square root of 9 is 3. The square root of 6 is just radical 6. And that would be my simplified exact answer. Unless we're specifically told to find an approximate approximates our decimals.